Hello, welcome everyone to the introduction to data science. So in the next couple of minutes, we will spend some thoughts about data science in general, and we try to stress the most important aspects of data science. So this will be done by the following agenda. First of all, we will talk about the different components that altogether build the field of data science. So as data science is an interdisciplinary field, we will show that it can be deconstructed into different components that all belong to different other areas of sciences. Then we will talk about the basis of data science. So we will talk about the big data era. As data, or especially the increasing amount of data that we could observe in the last decade or in the last couple of years, triggered the relevance or stressed the importance of data science, we will spend some thoughts about the data and the properties of the data. And then, after we talked about the data itself, we will also talk about the data processing. That means we will talk about the adequate way how data should be processed. And then, after we process the data, we also spend some thoughts about the ethical issues in order to discuss the issues that you should have in mind when you try to derive decisions from a data-driven perspective. So these 4 bullet points are the structure for the next minutes. So let us start with the elements of data science. So data science is a kind of new field of research area, and it can be deconstructed into different fields belonging to different other sciences. So here what we can see is that data science can be deconstructed into fields of computer science, especially the field of software development and machine learning, and into some components of the mathematical and statistical understanding. Here you do need a methodological domain knowledge in order to be able to process data and to know about the underlying methodological aspects that you have in mind, or they need to have in mind when you derive data-driven decisions. Especially the machine learning field is a component that is linked to the current AI discussion. Therefore, it is the machine learning itself, but also traditional methods like statistics, linear regression methods that belong to the field of data science. And then the domain knowledge is also an important aspect if it comes to a data science project, because it is the research question, or the question that is derived from the domain knowledge, which is basically the starting point of every data science project. So in order to dive into detail, let us think about the classical data science project or a normal research project, if it makes it easier to you. Every data science project starts with a research question. And this is why the domain knowledge is a relevant aspect in the field of data science. Because normally it is the research question which is the focus of the data science project, or in other words, it's the adequate answer to this research question, which is the purpose of data science. Therefore, it's necessary to have enough domain knowledge in order to ask the right questions that can be solved data-drivenly. And here what we observed in the last years was that those data science related research questions were mainly derived from economics, business administration, or computer science related topics. And what we are talking about in the next sessions is social science. Therefore, it is relevant to have the domain knowledge of social science or economics or business administration in order to ask the right questions that need to be answered in a data-driven way. And then after the question is asked, you have to be able to find the right methods or the right models in order to answer your question. So therefore, you do need the mathematical and statistical background in order to find the right model and also to define the right explanatory variables for your research question. That is, you need domain knowledge in the field of statistics and mathematics in order to build the right model and in order to find the right variables for your research question. And then after you define the model and the research data that you need you need to be able to get the data out of the World Wide Web, out of the system, or to create the data in the field of questionnaires or sensor data. Therefore, the domain knowledge about computer science is also necessary in the field of data science. That means you have to be able to get the data via APIs out of systems, or you have to be able to get the data out of the World Wide Web via scraping, yeah, and you have to be able to do the programming itself. Here you need the programming language of normally Python or R, which are the typical questions, which are typical languages which are applied here. Those three topics all together form the different disciplines of data science. And maybe one additional skill which can be subsumed under domain knowledge is also the design knowledge. Because if you think about the research question, which is derived from domain knowledge, and then which is then answered in a mathematical statistical way based on computer science, you also have to design the answer or the result, the outcome, in a way that this person who asks the domain question, the domain related question, is able to understand the answer. Therefore, the communication, so the domain specific communication and designing is also a relevant aspect of data science. So then, if you dive more into detail, which models are relevant? So when it comes to the modeling, we are currently in the area of artificial intelligence, which is from a methodological point of view, most of the time the same as talking about machine learning. So as machine learning is a subfield of AI, there are algorithms which are trained based on large data sets. Then you also need the coding experience, so what we subsume under software development, which means that you have to be able to do the programming, to do the data processing via Python or R, for instance. So there are a lot of open source software packages, and here it's the Anaconda Navigator, which is currently the state of the art for current data science studies. And then as well, what we mean with traditional research is that we have to study the subject in a detail which is necessary in order to answer the domain-specific question. So and these components all together are the components that all together build the word data science. And as you can see, all the components are coming from different scientific areas. Therefore, you can also think about data science as a combination of different existing scientific studies. So in order to provide a definition of data science, it is not that we talk about data science right now as the first time. So the first data science goes back to the 1960s. And here, it was basically the idea that it is necessary to understand and interpret large amounts of data. So, and as in the last 30 years, the amount of data that is available, especially in the last 10 years, due to the digitalization, due to social media, we do have an increasing amount of data that we can analyze. The evolution led to the field of data science was basically a scaling up, and now also comprises new systems and the computer studies. So therefore, the field of data science is, in a nutshell, the scientific method to extract knowledge or insights from big data. So when it comes to big data, what makes big data big? And here we try to find or we try to provide a definition about the term big data in order to provide some idea what big data is about. So when it comes to big data, they are the so-called 5 V's that are relevant in order to define big data. So the first 3 V's are volume, velocity, and variety, which are basically the, if you want to say so, traditional parameters of big data. So those three properties make it big. And then there are also two other properties of the big data phenomenon, which is basically the veracity and the variability and volatility itself. So these are basically the five components that we now want to discuss in a bit more, let's say, detailed way. So when it comes to the volume, I think everyone would agree that the quantitative amount of data increased dramatically in the last years. Here, it is not only the quantity of data itself. This is basically due to social media, due to Twitter, Instagram, Facebook. People are eager to upload data and to provide information about themselves. Yeah, it is. It is also about the data saving. So you have to have in mind that you need a scalable service, for instance, in order to deal with the quantity of data that gets produced. So it's not only the volume itself, which is in scope of of the big data phenomenon, also the storing of the volume. Yeah. So therefore, we talk about the increasing amount of availability of data, but also about the challenge to data service and about the scalable infrastructure that you need in order to address this increasing volume, which is still increasing, and there is no end to see. So then, based on the volume, you can talk about the velocity of the data. The velocity is the speed of the data. So that means that new data is generated in a speed which is dramatically increasing or dramatically increased in the last years. So coming from the world where you get daily news, we are now in the era where you get news every second, where you check your smartphone or your internet, where you can get updates every second or in an even inter-second way if you talk about investment banking, for instance. Therefore, the speed makes it even harder to analyze data in terms of data synchronization. However, the speed itself is one of the properties of the actual big data field. So then we also find the variety of data increasing. That is, we are not talking about traditional data that is stored in a so-called structured format, which is data that is stored in an Excel sheet or you get out of a computer system when you are at work. We also now have data in a format of text, images, videos, or sensory data. What we are now facing is like we are in the era of chatbots right now, like with ChatGPT, for instance. We see that we are already able to chat with a program based on text data, and we get automatically generated texts back. So this model comprises a huge data set of text available in the internet and was able to digest the information which is provided by the internet. Therefore, the format is called unstructured, and it subsumes text, images, and videos. And therefore, the variety increased because in a traditional way, like think about 20 years back, we were dealing with structured data stored in Excel sheets, but we were not at at this step that we were able to talk about the unstructured way. So here we do have, in addition to the volume and velocity, the variety of data that dramatically increased. And then the next thing is basically also kind of important, especially if you think about elections that happened recently. Um, there's the veracity of data. So the veracity of data means that there's the quality of data, which is also changing. Basically, as a result of the variety and velocity and volume of the data, we are also facing the challenge of varying quality. Yeah, like the source of the data differs, the quality itself differs, And we have to be aware, if we are using models based on big data, that we can control, or that we should control, for the quality of the data that we put into our models. Therefore, the veracity of the data is an aspect that we need to have in mind when it comes to big data applications. And then at the end, we are also dealing with variability and volatility of the data. That means that the incoming information stream, can be characterized also by fluctuations. So um, that means if we are collecting data, we have to be aware that we are dealing with kind of volatile data, especially when the velocity increases, like the volatility of the data also increases dramatically in most of the use cases. Therefore, we need to ensure that we do have a stable flow of data, and that the data has a constant value for the project. Yeah. So therefore, these 5 V's are the cornerstones for the definition of big data. And probably another V that is can be mentioned is the value of the data, because what we now face is a collection of data, and the value of the data is not clear at the very beginning when we upload data. So if you think about, for instance, the current movement of healthcare data, um, we do upload data, for instance, when we electronically pay for medicine, or if we go to the doctor, and this data has a value, not for us, but for the application, or for some companies. They are interested in this data, and therefore the data has certain value, not for the use case that we uploaded, but maybe for other companies that are also interested in that. And therefore, it is also an issue with big data that the value of the data, of the whole data set, sometimes changes, especially when you think about different data sources combined. So this is basically these are the properties, or the most striking properties, of the big data phenomenon. So when it comes to the data processing, that means the data is there, and now we're interested in the way how we can process the data. We would like to present the workflow of adequately data handling. So here, um, at the beginning of the process, there is the problem framing. So as I said in the beginning, when it came to the interdisciplinary fields of data science, where the domain knowledge is relevant, or one critical aspect of a successful data science project, it is the same with the data processing itself. So the first thing what you need is, you do need information about the problem framing. So you do need the information about the problem itself. And then based on the problem, you need to gather the relevant data. So the problem defines the data that is relevant. Yeah? And then based on the relevant data, you have to bring your data into the format that you can use it. So having in mind the 5 V's of big data, this is basically a huge challenge in every data science project, maybe the most time-consuming challenge, to bring the data into the format that you can work with it. So think about synchronization of frequent data. So you do have intraday data, you have daily data, you have data for every second for different aspects, and then you need to find a way, for instance, to synchronize the data. And then when the data is there, you need to do the data analysis. So here comes a point where you need your statistical and mathematical background, where you have to run a proper analysis, and then you have to derive the right conclusions from the data analysis itself. So let's dive into the process in more detail in order to gain an understanding for that. So starting with the problem framing, we need the research question, and here we do need the competence to ask a question that is worth it, and that can be answered by a data science process. So ask a question that can be answered in a data-driven way. So then, after the question is asked, we're done with the problem framing. We need to gather or collect the right amount of data. So here, the questions that you should ask yourself is, how do I collect the data? Do I get it out of sensors? Do I get it out of APIs? Do I need to conduct questionnaires in order to get the data? Is there any data out there that helps me to answer the question? Yeah? And then derived from this question, you already have to think about the data structure. So the structure, the way you collect your data determines the quality of your results. So if you think about text data, for instance, and you want to merge unstructured text data with structured data, like for instance, uh, daily data of revenue or daily data of personal hours people worked or manpower that you need in order to solve a project. Here you need to be aware of the different structure of the data that you merge, and you need a final picture of the structure that you want to achieve. Then, based on these thoughts, you need to do the so-called data cleansing. That is, if you collect data, you will face issues like missing data. That means data, if you merge data, you might not have data for all timestamps for each variable that you collect. So then you have to think about how to deal with those issues. So a good example is if you use daily data, for instance, you might have data from Monday till Friday for your variables. For some of them, you also might have the Saturday and Sunday, but maybe for some of them not. So if you think about weather data, for instance, you have data for every day. But if you think about, for instance, your workplace or your university, and you think about people at your place, you probably might only have data from Monday to Friday or Monday to Saturday. So then the question would be, how do you deal with the Sunday? Is it a relevant day? So do you need to extrapolate your data that is missing, or do you skip the Sunday in your analysis? And this heavily depends on your research question. The other thing is when you have in mind the variety of data, so the variety aspect of the big data phenomenon, how do you deal with outliers? So if you run or if you want to run a data-driven analysis, you have to be aware of um, data and outliers. So if there's one extreme day, for instance, or one extreme observation that is there, however, maybe not that relevant, you should think about finding a way how to deal with those outliers, so that those outliers don't distort your general result. So especially the recent COVID, for instance, the observations during COVID are also a nice example of outliers. So if you want to have an analysis in general, do you include or exclude COVID times? Because especially during the lockdowns, you do have extreme outliers in some aspects. So if you think about, for instance, traffic in the streets, traffic in the air, those times are a classic example for outliers, and you have to think about how to handle it. So, and then the next part is, if you have your data collected, you have to think about the sorting of your data. So in a way that you always have to think if the effort is worth it. Yeah, so if you sort your data, you have to find a useful way how to do it, and how do the sorting of the data fit to the problem. And at the end of the day, what you need is a clear structure of your database. So in the ideal world, you do have a clearly and well-documented structure, a clear structure of your database, and a database which can be enriched easily when there is an update in the data itself. So, and here it is also, when it comes to data cleaning and preparation, the part whenever you start a project, you begin your project with a so-called draft, which means you don't work with a full data set at the beginning in general, because collecting data is linked with costs and time. You start with a small example of the data, and you try to test your theories, and you try to test your techniques based on this fixed smaller sample that includes all the variables, but maybe not with the amount that you probably take only 1 year of data or 2 years, and not, let's say, 10 or 20 years, or all the data that is available. You start with a so-called MVP, minimal valuable product, and in order to test or to answer all those questions which are raised here. And then when the data set is prepared, you're ready to go to start your data analysis. And here is now the mathematic or the statistical component that is relevant or becomes relevant. Because when it comes to the data analysis, you have to be able to choose the right modeling, and also you have to be able to find the right presentation of the results. Yeah. So here you have your data input there, and now you try to squeeze or to derive the relevant information for the research question out of it. So what kind of methods do we use here? In general, you can separate the methods that you apply here into two components. There's, on the one hand, the interpretable part, which is basically statistics, econometrics, and mathematics. There you have models where you can interpret each component individually. So every variable has a meaning, and you can estimate the variables, and then you see how these variables react, and how the value of the variable changes if you change, for instance, the input data. On the other hand, you do have the so-called machine learning algorithms, which are called black box models, or non-interpretable approaches. That means if you have a large set of data, you apply those machine learning algorithms because you typically apply those because they are able to digest larger amount of data, and they are able to find patterns in large data sets. However, this comes with the cost of the non-interpretability. That means trained machine learning models are not that easy to interpret anymore. However, here I want to add there are techniques, so-called explainable AI techniques, which are there and that work. However, when I talk about data science here in general, I talk about the industry standard, put it that way. But have in mind that also these machine learning approaches now are under scrutiny, and there are already some techniques in science, especially in science, that try to overcome the shortcoming of machine learning. However, the finding the right model is a relevant step towards adequate data-driven results. So these are basically the steps you have to conduct in order to achieve this point of data exploitation. That is, if you now have the results derived from your model, you have to think about the output itself, and you have to discuss the results in the context of the problem framing. So here comes the domain knowledge again into the workflow, because now you have to match the question with the results. And this is basically the part where you need the design skills as well, those that I mentioned before, because in a normal data science workflow, it becomes more and more technical the more you go to the right in this workflow. So especially here in the problem framing is dealing with the domain knowledge, and here it becomes a more technical issue. Get the data, it's like more than the computer science issue. Data cleansing and preparation as well. So it's really technical part where you might lose the overview if you're not a domain expert with a computer science background. Some domain expert might not understand what is going on here. And then the data analysis is the field of statistics and mathematics. And if the domain knowledge and computer and mathematic knowledge are not the same person, are not embodied in the same person, because normally there are more persons involved in a project, it is relevant then to translate the results which are generated here into a form that the person which typically has the domain knowledge and is not involved in the data cleansing or the data analysis steps, that this person understands the answer. This is basically one of the biggest challenge when we think about social data science, so that you have to translate the technical results again into format that the person who asked the question is able to understand the answer. And here is a kind of undervalued skill, I would say. It is a design skill that you need to understand how to present the answer to the person who asked the problem. So this is basically the ideal workflow, and in the upcoming sessions, we will find projects in order to, or we will discuss projects in order to fill this skeleton with meat, so that you get some examples of ideal projects, and that you get some more idea about each step in this project. However, we stop here when it comes to the data processing process, and spend some more thoughts about the ethical issues that we need to clear before we start working with data. And as data or decisions derive from data, as we can see, for instance, now with ChatGPT, where we can ask several questions and we get the answers, we do have to be aware of that data-driven decisions need to be in line with our ethics. Yeah, because computer science or systems don't have moral, don't have ethics. Therefore, it's up to us to define what is an ethical issue and what not. So before we talk about ethics in the context of data, let us provide a brief definition of ethics. Yeah, typically ethics are there in order to answer the question what is right and what is wrong. So therefore, the term ethics goes back to the Greek. Yeah, it's derived from ethos and its habit or custom. And these ethics instruct us on what is right and what is wrong. Most of the people are mixing it up with morality. However, in a natural sense, what is good? We as humans live in a society, and our society has rules and regulations, and therefore those ethics deal with the feelings of laws and social norms which determine right or wrong. Yeah. And if you think about, for instance, genetics or genetic studies, there we do have some rules for genetics, what we are allowed to do and what we are not allowed. But when it comes to the field of data, if you go to the internet or you upload data there and the data is processed, also now with ChatGPT, for instance, it is not that clear where these limits begin and where these limits end. And this is basically a kind of international issue, whereas now different continents, for instance, the European Union or the United States, deal differently with ethics. And politics are working on AI standards or AI ethics and publish documents that try to put some boundaries on data-driven research in order to be in line within our European, United States, or Chinese ethics. So when it comes to data-driven decision, what is the deal with ethics in data science? So first of all, when it comes to the decision made on data, so you don't have to be a statistician or mathematician in order to follow this discussion. Here, it is a simple question: which decisions should be made or can be made based on data, and which shouldn't? So the best picture is like a self-driving car, for instance. Yeah, if you think about a self-driving car, who should take the decision? Who should take the decision if an accident, for instance, is unavoidable, and if this car crashes directly into the accident and then puts its driver into danger, or the decision of going left or right with the consequence of maybe hitting into another car or hitting a motorcycle rider, for instance. So who is taking this decision? Yeah, or should this decision be drawn based on data, or should it be your own decision? So this is basically a good example when it comes to ethics based on decisions. Another big area is privacy and confidentiality of data. So which data is private, which is confidential, and which data should be publicly available in order to be part of a trained data model. Yeah. And the next thing is like the ownership of data. Yeah, like who owns the data? And if you upload data into the internet, are you the owner, or is the platform the owner because the platform asks you kindly in order to confirm that you agree with the data processing standards of the platform, and you probably lose the ownership of your own data. So these three are the currently largest ethical issues from our point of the project, and here we would like to dive into detail to provide some information. So the first thing is, when it comes to the decisions, you should ask yourself who is directly impacted and who is indirectly impacted. These are two different topics. Yes, so your first thing is, if you want to derive a decision, who is directly impacted and how, based on the decision. And then the more interesting part, even, or the more tricky part, is who is indirectly impacted by the decision. So coming back to the picture of the self-riding car, if you are the rider of the car, if you ride the car, you are directly impacted if you are in front of an accident and you see there's no way to avoid a crash right now. So you are directly impacted. And then the persons around you are indirectly impacted and might be directly impacted if the self-driving car chooses to turn into your direction then. So therefore, before you start a data science project, you have to be aware of those two questions. And this is basically the point where the person with domain knowledge should talk with everyone who is potentially affected in the project. The next thing is, when it comes to big data, what is the privacy and confidentiality of the data? Can you ensure that the data that goes into or flows into your data science project is private and confidential? And the next thing is, can you ensure that you're allowed to use the data that you need for your models? For instance, if you think about personal related data at work, for instance, days of sickness, for instance, or the whole data that is collected by banks or by insurances, for instance, this is personal data, which is highly personal and therefore falls into the era of data privacy. And therefore, if you want to work with such a data, or if you need to work, how can you ensure using this data by taking privacy of individuals into account? So here in this stage, it's normally the data anonymization or data pseudonymization, a field of data where you try to find a way to circumvent data privacy issues, or data protection issues by by using data anonymization. So you try to get rid of all the individual properties of the data so that you cannot or you get the relevant aspects of the data, but you're losing like the information by whom this data is provided, for instance. So therefore privacy and confidentiality is a recent topic, especially when you think about the ChatGPT discussion. Like ChatGPT is a model that is trained on a huge database that is published or that is derived from the World Wide Web. And here we do have the issue. If you ask, for instance, the ChatGPT, please write a book or a text like Dan Brown would do, then you get a text. And this model is trained on data or on books written by Dan Brown, although Dan Brown has never agreed on his books to be part of this training. So this is basically one example how to probably get an idea about the issues with privacy and confidentiality. So, and then the next thing is the ownership. Like who owns the data. And if you upload your data, as I said, you most of the time are asked if you want to share the data, if you agree with the common user licenses of this platform. So here we do have the question like who owns the data, and the more interesting question from my point of view, like who is accountable for that. So, and this accountability is not only of the data ownership, also of the model ownership. For instance, coming back to the picture of the self-riding car, if you are not riding the car by your own, but the car rides itself, and you're involved in a crash, like who is accountable for that? Is it you because you decided freely to let the car ride, or is it the software engineer or the software producer who provides the software for the self-driving car, or is it the car company that sells you this self-driving car? So these are the relevant questions that you should be available to answer when it comes to the ownership. And here, in order to start a serious data science project, you should be able to answer or to find adequate answers to all those three questions, and to find answers where all people involved can live with. So with these words, I will end this session. You will find all the sources that are the underlying literature of this class here in the attachment of the slides. Please go through it if you feel like. And herewith, I end this session now.